All right then. So I'm sorry. All right then. So in this sections, we are going to learn about the pointers. So understanding the pointers is the fundamental thing in the C programming. So before that, let me clean up this code and let me open up this multi-command editor, and we are going to discuss about the pointers, right? So a pointer is a variable that stores the memory address of the another variable. Pointer is nothing but it's a variable which stores the memory address of another variable, right? So when it comes to pointers, we are working with two different two operators. What are they? Oops, two operators. So one which is this star and another one which is this ampersand. So star, we can say this is the value of operator, and this is the address of operator. So the star symbol, the asterisk symbol, which helps you to get the value from that specific address, and the ampersand symbol, which helps you to get the address of a very specific variable. For instance, let's say in the memory table, as I told you, so we have the address and we do have the variable and we do have the value for it, right? So let's say I'm going to create a variable as age, right? Let's keep it in the mind. So it will keeps in something like this random address. Okay, so I'm going to give a variable name as number, and I'm going to keep the value as 20 in it. So, and I'm going to get the address of this variable and I'm going to put it into the pointer variable. So that pointer variable needs to be stored somewhere, and that is randomly generated by the compiler. And that's the pointer variable. I'm just going to keep it as ptr, and I'm going to supply the value as the address of this specific variable. What is the address of the specific variable? ff635. So when I directly access this pointer variable, what is the value I get? The address. But when I use the star along with this pointer variable, so I will access this address and the star will fetch the value from that address. So what is the value that we have? 20. So that's the reason of having these two different. So to first, how to store this address as a value. So I will use this ampersand symbol to collect this variable address and store it in this variable. If I access it directly, the pointer variable, I will get the address. But if I use star along with this pointer, I will get the value inside this address. All right, that's the key point, right? So let's try to understand how exactly it's been working. So hash include stdio.h and int main, open it, and int number, okay, int number equals to 20. Then we are going to define a pointer variable as star ptr, right? That's a variable which we are creating. So now I need to get the variable address. So I need to get this variable address and I need to put it into this pointer variable. So ptr equals to ampersand number semicolon. So now as I said to you, so if I am trying to print, so printf like value in the pointer variable colon percentage, okay, colon. So if you want to print the address, you need to use the percentage u. Then if you simply directly print that pointer variable, and let's see what do we got. Return 0, say this changes, adjust the spelling, and run the program. There we go. So we are getting some random address over here, right? So if I wish to get the value which stored in that pointer variable address, pointer value address, that is going to be a number, so percentage %d, and then I'm going to supply this the star symbol. So if I rerun this, now you should get the value. So this is the address of that number variable, and this is the value which is stored in that particular address. So let me add /n and /n. save these changes. Now if you run this, you should get it like this. All right. So to make it more complex and interesting, so what we can do is we can store a double pointer variable like PTTRS pointers. So all I can do is I can simply store an address of a pointer variable into another pointer variable. Sounds interesting, right? So I'm just going to copy this and I'm going to paste it. So if I let me paste this. Okay, so over here, if I print this pointer variable directly, and if I use single star and if I use double star, see what's happening. So here, let's talk about, so here PTRS. So in this pointer variable, what I'm trying to store this value, right? So if I directly access this pointer, what I got an address. What is that? GG858, which is the address of this pointer variable, right? That will be printed over here. If I use star pointers, so what will we got? We will get the value which is stored in this address. What is the value which is stored in that address? This one, f of 635, which is the address of this particular variable. So I get this particular address over there. If I use double pointer, what I got for single pointer, I'll get this. For double pointer, I'll get this value. So this is what happens when you try to store multiple pointers. So you can add a number of pointers unless you are so damn confident in what you're doing, right? So if I click save and if I run this, I forget the semicolon. It's happening a lot, sorry. So if you click this, now you can see we got one address and we got another one address and we got the value of that particular variable, right? So this is what happens every time whenever you are using a pointer inside a pointer again and again, right? So pointer plays a major roles when you're working with the different perspective. So now let's talk about how to work with the pointer in arrays, right? So what I'm going to do is I'm going to create one array, int arr, an array, and I'm going to supply 10, 20, I'm sorry, 10, 20, 30, 40, and 50, right? Then I'm going to create one more pointer variable along with it as APTR, like array pointer, something like that. Save these changes. Okay, so now what I'm going to do is I'm going to okay, let's keep this in a separate line to avoid confusion. So int star APTR is equals to array. So I'm passing the array reference for the value of this particular pointer, right? So directly. So usually what we will do, we will pass the address and we'll supply it to here. But now I'm passing the entire array as a reference to, as a value to the directly pointer itself. So pointer to the first element of the array. So what we are doing here, this particular, it's going to pointer to the first element of the array, right? So now if I wish to print, so printf value at array of 0th index. Okay, value at array of 0th index. What I have to do, all I have to do is to say %d/n comma star APTR, right? If I print that, what will happen? So it will print the first index of that specific array. Let's see, save the changes, and if I run it, you can see we are getting the value as 0, right? Because we passed the entire value of this array as the reference by accessing the star. We are not using ampersand symbol. I'm using the star to get the value of this complete array. Now I have the complete array first element in this array PTR. Now if I need to access the second index, what I have to do, I have to say APTR plus 1. That's it, as simple as that. Now you have the second index on that particular array. Oh my bad. Okay, you should add this bracket, otherwise you will get the answer as 11 only, because it's accessing the first element and it's adding 1 with that element. So we don't want to get the first element and add 1 with that element. We need to access the second index. So supply it like this. That's what I'm wondering. All right. Now you can see we are getting the second index, right? So this is how you should work the pointer with your array, right? I hope you understand how the arrays and everything is working and how they are playing some crucial role in the C programming, right? So without wasting your time further, let's jump into the next concept. All right then, so in this section, we are going to learn about the dynamic memory allocation. When it comes to pointer, we need to also work with the dynamic memory allocation because that's the most important thing, right? So let me clean up this code. And in this section, we are going to discuss about the dynamic memory allocation, right? So in C programming, dynamic memory allocation is a mechanism by which you can allocate memory during the execution of the program. So here, the dynamic memory allocation is nothing but it's a mechanism which helps you to allocate the memory dynamically during the execution of the program, right? That's the dynamic memory allocation. So the standard library provides you the functions. We have 4 different functions. One is malloc and calloc and realloc and free. So these are the 4 different functions that we have to manage the dynamic memory management. All right then, so let's start with the malloc. So let's see what is malloc. So basically malloc means the memory allocation. So this malloc is a function that allocates a specified number of bytes of memory, that allocates the specified number of bytes of memory and returns pointer to the beginning of the block, So this is what the mallocs do. All right. So let's see a simple example program. So how to work with the malloc. So here, so I'm going to use the hash include stdio.h. Then I'm going to use the standard library for header files also, std hash include stdlib.h. Yep. All right. So int main, open it, and at last we should use the return 0 semicolon. Okay, so now I need to create a pointer. So let's say star ptr. So now we do have our own pointer variable. So first what I need to do is we need to allocate the memory into an integer. So right, so we need to convert the memory into an integer. So to do that, what I'm going to do is I'm just going to say allocating. This is the place where we are allocating memory for an integer. Okay, or an integer. Yep. So ptr is equals to, so what memory that we are trying to allocate. So we are trying to allocate an integer pointer, and using malloc, and you need to give the size of int. We need to supply the size of basic int, whatever the size of the integer data type, that should be allocated for that specific pointer dynamically. So if that pointer is equals to null, we need to make sure that pointer is not equals to null. If that pointer is equals to null, which means the memory allocation is failed, printf /n, the memory allocation is failed, right? So semicolon. All right, and then we are going to return it as 1. So we want to exit without any error, right? So exit, this is the place where we are trying to exit without an error. All right, so right after this if condition, so what I'm trying to do, if this is not executing, if this condition is not executing, which means the memory allocation is successful. So for that very specific pointer value, I'm trying to assign 42 as a number, right? Then if you're trying to printf the value of pointer colon percentage d comma star ptr, that's the pointer variable. So once the memory allocation and everything is the process, whatever we are trying to do, if everything is finished, we need to free the memory which we allocated. So that's the reason, that's the place where we need to use the free. So free is the function which helps you to deallocates the memory blocks, which means it helps you to remove that allocated memory blocks, right? So I need to remove that memory block which I allocated. So free that pointer, semicolon, save these changes. If everything is running perfectly and the memory allocation is done perfectly, then we should get the answer. Let's see. There we go. See, we get the answer as 42, which means this memory allocation was created with the 4 bytes. So 4 bytes is created for this very specific pointer dynamically, and that pointer variable carries out this specific value, and this specific value it's been printed, and the allocated memory blocks are being released. So this is the best practice to work with the malloc. All right, so now let's check it out, the calloc. Let's see what exactly happening when you're working with calloc. So the calloc is the contiguous allocation. Contiguous allocation. So do you remember the place where we are use the contiguous allocation? We use the contiguous allocation in the array, right? So basically the calloc function allocates a specified number of block memories, each with a number of specified number of bytes. So what I'm trying to say here is, so the block memory will get assigned, and each within that specified number of bytes. So function, it's used to allocate a specified number of blocks of memory, each with a specified number of bytes, each with a specified number of bytes. That's the calloc. All right, so all you have to do is to one simple thing, which is just to change this to from malloc to calloc, right? Calloc. But one more thing, malloc will use the default size, right? But in this case, I can specify what specific number of bytes I need to use. So if I need to use 5 bytes out of 8, I can use that, right? So all I have to do is to supply the very specific size, and okay, so and right after here, instead of assigning it as a single, right, instead of assigning it as a single value, I'm gonna assign like I'm gonna write a function, write a use of for loop to create, to make it look like an array. I less than 5, I plus plus, open it, and arr I is equals to I plus 1. Simply whatever the I value, just add 1 with it and then store it inside the array. Then we are trying to print that array value. Printf arr. Oh, this is supposed to be ptr. That's the pointer variable which we have, right? So the array value, so ptr of %d equals to %d / n. After this, first I need to bring the I value, then I need to bring the ptr of I value, semicolon, right? So here we don't need this, delete it. Then let's free that memory spaces. Say if you run it, you should get the 1 2 3 4 5, right? So now each of this index will carries out 5 bytes. Each and every index will carries out the 5 bytes, the custom memory allocation, so which we mentioned it over here, right? That's the contiguous memory allocation. And the last one is the realloc. Last one is the realloc. So basically realloc is a function is used to change the size of the previously allocated memory blocks. Right? It can be used to expand or shrink the memory block, right? So that's the realloc size. So over here, so we having this calloc example over here. Let's use the same thing. So now if you wish to reallocate the memory size, right? Let's say if you wish to reallocate the memory size, instead of 5, I want to reallocate into 3. So what I can do is right after here, the place where we are printing and everything, this is the place. So I'm wishing to reallocate the memory blocks, right? So over here, using the same pointer variable, I'm trying to reallocate it. So pointer int that pointer variable, and using realloc, 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 and for that very specific pointer, I'm going to redefine the pointer size into 3 times the size of the int. That's the size which I'm trying to reallocate it, int, semicolon, right? So again, I'm going to do the same thing. The reallocation, if the fails, the memory reallocation is failed. Memory reallocation is failed, and returns it with 1 without any fail-safe error. Then I'm just going to copy this and I'm going to say 3 times of it, or you can keep it as you wish. Okay, so here let's keep it the same thing. Let's try to print it. So if that is, I'm not going to change anything else. I'm just trying to change the size of the byte, right? So if I run it, here we go. See, after reallocating also, it's working perfectly fine. It's not showing any issues or any error, because we are just trying to reallocate the memory bytes in bytes, 3 bytes, right? So the maximum size of an integer, it's all about 4 bytes or 8 bytes, depending upon the operating system what you're using. So if there is any issues that could have triggered, and it will simply raise this error message, but it's not raising any error message. It's working perfectly, and it's freed at the end of the point, right? So you have to make sure every time when you're trying to do allocation, at the end you should free that memory blocks. All right, so that's what over here. So these are the different types of dynamic memory allocation that we use a lot in a development process. All right, I hope you understand. So without wasting your time, let's jump into the next section.